All right, number 17, solve the equation, and we've been given 4096 to the x power equals 8. And there are probably really two primary ways that we could solve this, and I'll go ahead and show both here. The first way that you could solve this is to, first and foremost, let's, for the moment, concentrate only on the bases here, right? On the left-hand side, the base is 4096, the exponent is x. Here on the right-hand side, our base is 8. The exponent, we know, is 1. And so we're going to focus on just the bases for a moment. So 4096 and 8. Because what we want to try to do is we want to try to get the bases to be the same, and that will make the task of solving for the exponent a whole lot easier. So what we're going to do is we're going to ask ourselves, which number is bigger, 4096 or 8? Well, clearly 4096 is larger, so what we want to do is we want to say, all right, is there a way that we can rewrite 4096 using the base of 8, meaning 8 to some power will give us 4096? Well, if you have a exponent kind of cheat sheet with you, which you can pick up in the Student Learning Center, I have one here. It looks different than the one in the SLC, and if you like this one, you can email me and I'll be happy to send it to you. But they all work the same. All the information is the same. You can see that if we look at 4096, we could take the fourth root of 4096 to give us 8. So what this is saying is that 8 to the fourth power is 4096. So coming back over here, we know now that 8 to the fourth power is 4096. Here, the 8, we didn't do anything, so we can bring it down. And now we've got ourselves like bases, both 8. So returning now to the beginning and starting to take into account the original exponents, well, we have 8 to the fourth, which is just, remember, 4096, but now we have to include the x power. So this is 8 to the fourth to the x equals, and again, we didn't do anything here on the right-hand side, so this is still 8 to the first. And if this is an equation, let's go ahead and start cleaning this up a little bit. Well, we know that with an exponent, a power to a power, all we have to do here is multiply, and so we end up with 8 to the 4x equals 8 to the first. And now that the bases are the same, that means that our exponents also have to be equal. And so now what we can do is simply say, all right, if we know the exponents have to be equal, off to the side, or I guess down below here is fine, we can set these two things equal to each other to solve for x. So we're saying 4x equals 1. Well, we know if we want to solve for x, we can divide by 4 on both sides. And so we're going to get x equals 1 over 4. All right, this was method 1. And the second method that we can take a look at, we'll obviously get the same answer, just go about it a different way. So method 2 here. Now method 2, we're going to again start with what we originally had. So 4096 to the x equals 8. And now in this case, what we could have done was, well, let's solve for the exponent. And in this case, because x is being expressed as a power, as an exponent, if we take the log of both sides here, what that'll enable us to do is take this exponent and move it out front. So now what we have is x log 4096 equals log of 8, and if we want x all by itself, we'll divide both sides by log 4096, divide by log 4096, and we'll end up with x equals, and then for something like that, you would want to use your calculator. So let's see, we're saying log of 8 divided by log of 4096, and we end up with 0.25, which is, if we express it as a fraction, 1 over 4. So again, we still get the same answer either way. So Whichever method you prefer, unless of course your professor has explicitly told you to solve it one of these two methods, then it really is kind of user's choice. So either way, number 17, x equals 1/4.